Hi guys, we are from Team Horsepower 2.0 and these are our team members. My name is Mandeep.
My name is Wong. My name is Go.
My name is Prasad.
And my name is Manraj.
And we are going to be presenting our prototype today. Thank you. Malaysia, a global powerhouse in the semiconductor industry, commanding 30% of global backend capacity and 7% of total semiconductor trade. This is the truth of Malaysia and we are very proud of this. At a smaller scale, our drainage system problems are still unresolved and urban areas with aging and poorly maintained infrastructure cause flash floods. Just recently, there was a real-life flash floods that caused people to be unable to reach home to break their fast. This is where our product comes into the picture. Let's see how Project SMARTFLOW will change the future of Malaysia and how it works.
Okay guys, next we'll move on to system design specification. I'll break this section down to three parts: input, process, and also output, like any engineering industry. First, let's look at input. SMARTFLOW collects data through various sensors. We have an ultrasonic sensor that measures water level, a potentiometer that simulates different rainfall intensities for testing, and two IR sensors. One simulates debris blocking the drain and another simulates waste detection. We also use servo motor to control the drain cover, which is indicated by green when it's closed and red when it's open. This is our sensing layer, where real-world data is collected. Next, we move on to the processing layer, where the real action happens. The ESP32 microcontroller processes all sensors data. It applies simple threshold logic to determine the system's status: normal, warning, and also critical, based on the condition like water level or debris detection. It then sends this processed data to an IoT software platform for real-time monitoring. Finally, let's talk about the output. Instead of using laptop application, the system transmits the data directly to an IoT software, which is something like this. This is how it looks like, the interface here. The IoT software can trigger alerts when abnormal conditions are detected, such as high water level or debris blockage. This ensures the system is monitored remotely and can take immediate action when needed.
So now we'll be looking at the working principle of our solution, SMARTFLOW. So first, our system is actually a combination of sensors, microprocessors, and actuators. So firstly, we have the ultrasonic sensor, which is used to measure the water level inside the drain. Next, we have the rain module sensor, which is used to detect rainfall intensity. This information is sent to our microcontroller, which is ESP32, which helps to process inputs. This input is actually next sent to our actuator, which is the servo motor and LEDs. And at the same time, this information is being sent to our IoT to upload in our dashboard. So next, now we'll be looking at the circuit diagram of our solution, which is produced in Walkway. So now we'll be looking at our circuit simulation in Walkway. So here, first we'll be explaining about the ultrasonic sensor. When the water level is less than 50 cm, the green color LED is being lit, so that water level is within safe levels. Next, when the water level is within 150 cm, an amber color LED is being lit. Next, when the water level is more than 150 cm, a red color LED is being lit to indicate dangerous water levels. So next, we are going to show the slider potentiometer, which is shown on the simulate rain. So over here in the serial monitor, you can see that the value of rain is changing. Next, so here we are using this push button and a substitute for the IR sensor, which is used to simulate debris detection. So when you see as the push button is being pressed, a red color LED is being indicated to show that the servo motor cover is being opened, and once the push button is released, the green color LED is being indicated to show that the smart cover is closed. Next. Now let me explain to you about our smart drain cover 3D design, which we use Tinkercad to design. So as for design explanation, for first part, purpose. The purpose of this smart cover is to prevent debris and waste from entering the flow of drainage. Next, the smart drain cover opens automatically when water level rises towards overflow. In terms of mechanical setup, the servo motor is mounted upright inside the housing and the horn clips are connected to the servo motor shaft to cover. And this allows for smooth rotation from the closed to open position. And lastly, in terms of design features, the smart drain cover is compact and realistic for urban drains. The design is lightweight, which is easy for actuation. Lastly, this protects electronics while ensuring functionality.
I'll now talk about scalability and also sustainability. So as said earlier, our ESP32 microcontroller has equipped with Wi-Fi and also USB. So it has wired communication, but so far we are only using manual data collection by simulating blockage and debris using pressure switches and also buttons. In the near term, we also like to deploy it across pilot neighborhoods, meaning we will test run our prototype to ensure that it runs smoothly. And we would then transition into citywide coverage using hub-based data storage or also AI-based analysis. And in the long run, we also like to become an regional integration with also automated responses. For the sustainable development goals, SMARTFLOW adheres to SDG 7 12 and 30. In the near future, we would also like to incorporate solar-powered panels instead of using lithium battery so that it increases its sustainability and also allows us to deploy it in rural areas. And for the 12 and 20 SDG, communities using SMARTFLOW could have better waste management and also higher awareness of their environment.
So, ladies and gentlemen, a green prototype is only half the battle. To create a real environmental impact, the solution must be economically viable and highly scalable. So now, let's look at the numbers. Currently, when we look at the traditional flood telemetry station that built by our governments require heavy civil engineers and costing upwards to 77,000 ringgit Malaysians per station. But we start SMARTFLOW companies to disrupt this completely because we believe that by utilizing industrial modules and rated sensors that running on off-grid solar powers, we can bring the commercial prototype and product cost down to just 1,400 ringgit Malaysians. That is almost 95% of cost reductions, allowing us to deploy high-density networks where traditional stations simply cannot go. So, but we are not just selling hardware, right? To create a positive, maintainable cash flow, we are building actually a recurring revenue ecosystem because our business model is a B2B and B2G models. We sell the hardware units for an upfront cost to 3,500 ringgit Malaysians and securing a 60% gross profit. And on top of that, we charge an annual subscription fee on our 600 ringgit per unit for cloud hosting, AI-driven alerts, and API dashboard access. This can actually guarantee our sustainable cash flow and use for our development and R&D process in the future. So, to enter the markets, our strategy is very simple, straightforward. Securing a sandbox grant to build 20 prototypes, deploying them in a flash flood hotspot for a 6-month period, and use that verified data to bid for government project and government fund. Next up, let's look at the market opportunity. Right now, the IoT environment sensor market in Southeast Asia is actually exploding because it is expected to project to hit USD 14.43 billion by 2032. Our primary targets are local city councils like MPDJs and BDKL. Why? Because 80% of urban flash flood don't start in major rivers, they start in clogged urban drains, right? This is the large mile gap that we need to fix. So, our traditional competitors like Siemens and Bosch are too expensive and the JBS stations are spaced too far apart. So, we SMARTFLOW act as a high-density CCTV of drains. We are cheap, we are modular, and we are fast to deploy. So, furthermore, the timing right now is just perfect because the Malaysian government has mandated heavy investments in climate resilience, right? With budget 2025, they are actually allocating 150 million ringgit, especially for local authorities to address flash flood, alongside with 3 billion for major mitigation projects. So, we SMARTFLOW is the exact low-cost and dynastic tools that these local councils need right now at this moment. It is financially sound, market ready, and positioned to save both millions in property damage and, more importantly, human lives.
As a conclusion, we have discussed design functionality, sustainability efforts, economic viability, and market analysis of our product. All the points given shows the feasibility of the product and the opportunity for better, effective infrastructure in Malaysia. This product will be revolutionary to Malaysia and other tropical climate countries with heavy rainfall, as it helps increase quality of life and allow for small scale and big scale applications. From Team Horsepower 2.0, thank you.